In my last video, we created a model endpoint for GPT-4o model in Azure Foundry. Now, I don't know about you, but my paws have been itching to test it. If you worked with AI before, you may be familiar with Python libraries like PyTorch, TensorFlow, and Keras. And that's awesome! But with agentic AI, you have a new set of libraries you can work with. Microsoft offers Semantic Kernel and AutoGen. Then there's LangChain and Crew AI. Google has Agent Development Kit. There's also OpenAI Agents SDK. Yes, there are tons and tons of libraries out there. The one we're going to work with is Semantic Kernel, which is helpful for creating enterprise-grade agent frameworks. Specifically, we're going to use Python for this course. But keep in mind that Semantic Kernel and many of these other libraries also support C#, Java, etc. I'm going to open up VS Code, which is my code editor of choice. You can use whatever you wish. Here I have the Era of Agents repo opened up. I have the GitHub link below in the description if you want to follow along. So the first thing we're going to do is create a virtual environment so that we start with a clean slate. The way we do this in VS Code is if you're on a Mac, press Command-Shift-P, and if you're on Windows, press Control-Shift-P, and we're going to click on Python Create Environment. I'm going to use the first option, and then we're going to use Python 3.13. So really make sure that you have your Python and pip upgraded so that this works seamlessly. I do want to install my dependencies, so I'm going to press Enter. While that's happening, let's take a look at our libraries. So the first dependency is Semantic Kernel. Of course, we've just talked about that. That's the library we're going to use. Then the python.env will help us load in our environment variables. So then the next thing we have to do is make sure that we have all our environment variables. We're going to fill out our Azure OpenAI endpoint, API key, deployment name, and API version. So let me show you how that works. So here I'm on the Azure AI Foundry page, specifically on the GPT-4o deployment, which we created in our last video. In order to obtain our Azure OpenAI endpoint, we need to copy this value. And in order to get our Azure OpenAI API key, this is where we get it from. Our deployment name is whatever you called it. In my case, I just called it GPT-4o. And then the API version, we can just copy from the code example here. So I'm going to paste the endpoint from Foundry, and then I'll leave you to do the rest of the variables. We don't accidentally want to commit this file to GitHub since it does contain our API key. And we don't want that to be floating around, unless of course you're fond of surprise charges in the thousands showing up on your account. So before we forget, let's just add our environment variables file to our git ignore file. Now let's get started with our first example. We're just going to invoke our model in 01 invoking model.py. First, we're going to import all our libraries, asyncio because we're going to work a lot with the async await syntax. Then os and .env to load in our environment variables. And semantic kernel. Specifically, we're going to be working a lot with Azure Chat Completion because this course is essentially all about chatbots. Now we're going to start with the main method. Notice it is async. You'll see this a lot in this modern-day AI agent coding. If you're not familiar with async and await, here's how it works. Await is our way of telling our program when to pause within a function before executing the next line in the function code. A great example is when we are waiting for the model to respond. There's obviously some latency when we invoke a model with a prompt and when we receive a response from the model. Async, on the other hand, stands for asynchronous, and it indicates your computer program can do other things while it waits for your function to finish. For example, even though we're waiting for the model to respond, we can still respond to user events, such as if a user were to create a new session. Got it? Then we're going to load in our environment variables. Now, here's where the cool part starts. We initialize the kernel, which is a component specific to the Semantic Kernel library. It essentially is a container that manages all the services and plugins needed to run your AI application. We're going to now add our Azure Chat Completion service and then all our Azure OpenAI variables, deployment, endpoint, API key, version. And then we have our prompt. For this course, each AI chatbot we build will be applied to a specific business scenario from Tabby, a company that specializes in a cat matching app. In this video, we'll invoke our LLM to generate a sample welcome email for a summer intern joining Tabby. We set the response to get chat completion for the prompt. Here we see the wait, and then we print the response. Now, this is a very simple interaction. We're just sending a single prompt to the model, so it doesn't qualify as a chatbot or an AI agent. And that's perfectly fine. The goal of this video is simply to introduce you to Semantic Kernel and confirm that we can successfully invoke our model. Now we can press Run to see our response. And voila! We have a very interesting welcome email. And of course, I'm happy. No more writing emails to interns from the heart. You might have noticed that we had to wait for the model to fully generate its response before seeing anything on screen. That's because by default, the output is delivered all at once. Now, this isn't an ideal user experience. First, it feels like the AI takes a long time to respond. And if the response starts going off track, there's no way to interrupt it mid-generation. That's why we prefer to use streaming to generate our responses. That's when responses are delivered token by token. The responses are perceived to be faster and keep users engaged. It allows for earlier interruption and is often more memory efficient for larger responses. So let's go to 02streamingmodel.py. The prompt this time is to write a detailed, inspiring message for the new intern, and it should include 5 bullet points of advice. You can take a look at the streaming logic here. This time, we're invoking a prompt stream and printing each chunk as we get it. Let's run this code. Now, this is a nice example for streaming because if the advice provided by the LLM doesn't match what you would normally give, you can totally interrupt the flow. In the next video, we're going to talk about history and context management so that we can start having conversations with our model. See you next time.